Alright, we're going to do a really quick video lesson on the Chapter 4 supplemental notes, adding and subtracting fractions. It's at the end of your, it's included in your notes packet, and if you don't need it, if you remember how to do this from last year or Alex makes enough sense to you, you do not need to watch these, but it'll be here as a reference for you. So adding and subtracting fractions really comes down to getting the denominators the same. So if we look at this right here, we've got 2/5 plus 1/5. What you want to do is since the denominators are already the same, you just write the problem and then add the numerators straight across, and then the denominator stays the same. 2/5 plus 1/5 equals 3/5. And this makes a lot of sense. If I have a piece of wood or a candy bar or something like that, 1, 2, 3, 4, and it's divided into fifths, and I have 2/5, that's the first fraction, and then I add another fifth, I'm going to end up with 3/5. That's the answer right there. So that's how you add and subtract, same rules for subtraction, fractions that have the same denominator already. Moving on to more complicated manners, if they have an unlike denominator, you have to get the denominator the same. Let me make sure I'm recording still. Okay. You have to get to the denominator the same, and this is what we worked on at the beginning of the class. So 2/3 minus 7/3. Here's your steps right over here. And remember, these are your notes. You can write all over them to help you later on when you're doing things. So number one, rewrite vertically. Not everybody will do this, but this is the way I like to do it. So you rewrite them up and down, then write an equivalent fraction that has the denominator the same. So I'm looking at the denominators, 3 and 7. What is the least common multiple that they have? And that is 21. So 3 times 7 equals 21. 7 times 3 equals 21. So you complete the equivalent fraction by multiplying the 7 on the top and getting 14. I'm just writing on top of this so you know what I'm talking about. This was times 3 on the bottom, so it's times 3 on the top. And then you have 14 21st over 9 21st. You add those together, or I'm sorry, it's subtraction. You'd subtract those and get 5 21st. And then simplify, reduce if it comes out to an improper fraction. Anything else, you have to take care of that as well. Other people will do it horizontally, keep it written horizontally and do it straight down. So there you will also see it like this. 14 and 9. So it's the same thing, just written the other way. I like writing it vertically because I think it helps when you get to the mixed numbers, which is what we are doing next. So, and again, same rules for adding and subtracting the fractions there. So those are fractions. What if you have a mixed number, a whole number, excuse me, plus a fraction in there? This is how you handle that. Same directions as above. Oops. So first step was to, right on the board, no. First step was to rewrite vertically, find the least common multiple is the second step, and then write equivalent fractions for that. So that's what you will see that we have done here. 2 and 3/5 right here. We're looking for a common denominator that it has with 7/10, 5 and 10. Both of them can go into 10, and you want to get the least common multiple, so you can have smallest numbers that you're working with. So here you go, 10. 5 times 2 equals 10. A 10 is already a 10 on the bottom, so 7/10 stays the same. You multiplied 5 times 2 up here, so you have to multiply 3 times 2 here and get the 6. All right. So now we have 2 and 6/10 plus 3 and 7/10. Do the fraction and the whole number separate. So I'm adding the fraction. 6 plus 7 equals 13. The denominator stays the same, right? 2 plus 3 equals 5. And now I have 5 and 13 over 10, which is a fine answer, but it's not in simplest form. 13/10 is improper. So you have to get that into a mixed number. And so let's do that. 10 goes into 13 one time with 3 left over, and then the 10 Denominator stays the same. Don't forget to add that whole number that you were working with before, 5, onto that, and so you come out to 6 and 3/10. Okay? So other way to do this that you might have been taught, and I'm fine with them either way, I understand it, is to convert these right here, so you know what I'm talking about, into into improper fractions. They're already mixed numbers. So 2 and 3/5 as a improper fraction, and improper fraction is 5 times 2 is 10, 13/5, that's 37 over 10. And now I have, don't have to deal with the whole number. I'm dealing with just fractions, but you follow the same process. You get the bottom numbers the same. So 5 goes into 10 twice. 13 times 2 is 26. And if you're not getting this, just pause the video and rewind it so you can see what I did. Now we can add the top numbers. I didn't work this out ahead of time, so hopefully I'll get it right. I'll make sure I get it right by writing down here. 13, 63, 63 over 10. And that's improper, obviously. Got to deal with that. So 10 goes into 63 6 times with 3/10 left over. We have the same answer? Yes, we have the same answer. So either way is fine, whatever makes sense for your brain. I used to always do it the vertically way, and then I'm thinking lately that the converting to improper fractions might be alright too. So, what other situations might you run into? That's on the second page of the notes, right here, especially with subtraction. So here we have a whole number, 8 minus 2 and 1/4. So as I'm rewriting this vertically, 8 minus 2 and 1/4, I have nothing to subtract that 1/4 from. So what you do is you borrow, and you'll see that that's what happened over here. I borrowed 1 whole from the 8. If I borrow 1 whole from the 8, it becomes a 7, and then I'm going to put that over here as a fraction. So you can write a whole number, the whole number 1, in any fraction form you want. Any number over itself is 1, so I'm going to choose a 4 over 4 because it matches the denominator I have already. Once you have that, then it looks more like the problems we were working with before, and I can subtract for the numerators. 4 from 1 is, or 1 from 4 is 3, and then the denominator stays the same. 7 minus 2 is 5. So you come up with 5 and 3/4. So just like subtraction that you've been doing since you were a little kid, you borrow when you don't have anything to subtract from. If you have a whole number, another situation here, if you have a fraction that's not big enough, and I'll do it over here just so you can see what's happening from the beginning. I'm subtracting. I have denominators that are not the same, so I'm getting them the same. I know that 4 and 3 both go into 12, so that's my least common multiple, or lowest common denominator, you might hear it. 4 times 3 is 12, so 1 times 3 is 3. This is going to be 4. Alright. Now, if I go to subtract 3 minus 4, I can't do it. There's, just like regular subtraction when you were a little kid. Same thing as the previous example. Borrow from the 8. And I borrowed 1 whole. I take that over here. Watch this part carefully because this is what people get messed up with. I'm taking that 1 whole. Like I said before, you can turn that into a fraction with any denominator you want. I'm going to choose 12 because obviously it's a 12 already and I want to make things easy and efficient. So the most common mistake at this point is people will subtract 12 over 12 minus 4 over 12. That's not what you're doing. You're adding the 3 to the 12. Because you started off with 3/12, right here, and I'm adding this to the 3/12 to get this, right? So now I'm working with 15/12 minus the 4/12 right here. And that's 11 over 12. Then I go and deal with the whole number, the 4 and 11/12. Okay. Again, you can convert this all into improper fractions and work with it that way if you wanted to. 8 and 1/4 minus 3 and 1/3, 32, 33 over 4 minus 10 over 3, and then get least common denominators of 12 on those as well. I'm not going to work it all the way through because it's going to come out to the same answer. Whatever way works best for your brain, converting them to improper fractions and dealing with the denominator, or rewriting vertically, dealing with the whole number and the denominator separate. Alright, so you will see those on Alex, and we'll work on them in class, and that's all for now.